Welcome to this node breakdown for MARDINI 2024 with Grayscale Gorilla. This is day 14, and today's node is the Cloud Shape Generate SOP. This node is a SOP level geometry node, so we can go ahead and drop it at the SOP level by typing Cloud Shape Generate. You will see that it has one input, but it doesn't require an input. By default, it'll just create this structure over here. This is just a bunch of points being represented as spheres, and this is going to be a rough estimate of the shape of whatever cloud you might be trying to create. So we use this as a starting point for generating cumulus clouds. Now keep in mind that this is intended for creating cumulus clouds and not for stratus or cirrus clouds. Basically, this is going to be for those poofier clouds. Now, over here, we have what is known as cloud species. This is just going to be a preset. The default mediocris is going to be somewhere between a flat cloud and a tall cloud, so it has this sort of range to it. When we look at cumulus, you'll see that these are flatter clouds, and when we look at congestus, it's these tall, stacked clouds. Going back to mediocris, over here, we can also change the shape using the shape offset. As we move through this, it's adjusting the seed, so it's auto-generating a different cloud shape. Over here, we have point separation. This is just going to define what size our points should be when generating this cloud. As we decrease this, you'll see that we end up with a smaller cloud, but also smaller points. The initial size over here is going to be increased in most cases because we generally won't be working with clouds at such a small scale, so you may push it up to 10 or higher. As for length and width, those are fairly self-explanatory. Length is the length of the cloud, width is the width of the cloud. We have distortion, and that's just going to be a noise pattern that distorts the cloud in some way. This is useful if the shape offset isn't exactly what you want and you want to add some distortion to it. Now, we also have flat bottom, and this is going to be defined by a height. As we push this up, the bottom moves up with it. Over here, we have an up vector, which defines which direction is up for this cloud. As you can see, it is 1 at the moment on Y, but we can change this to 1 on X, 1 on Z. We can do negative axes, just like that. We also have rotation, and that's rotation around the Y-axis. So that's just going to rotate our cloud around the Y-axis. So that's going to set up the general shape of your cloud. But down here, we have random scale per shape and secondary shapes. I'm going to disable secondary shapes so I can show you what the basic underlying shape looks like. And this is based off our point separation multiplied by the random scale per shape. Each one of these spheres can have a scale that ranges between 1 to 2 times this point separation. So if we drop this to 1, they're all going to be uniformly scaled. If we increase this to 3, you're going to have a much larger range. Now, as you can see, this is just a single flat layer. This is where we look at secondary shapes. So when we add secondary shapes, it'll add layers of detail over and above the existing shape. So this adds 1 level, 2, 3, 4, and so on. Displacement is going to be the amount that it actually moves up with each iteration. So if we increase this over here, you can see that we end up with a much higher displacement in the y-axis, but a value of 1 is generally going to be okay. When we look at spread, this is going to be the spread along the other axes other than the y-axis. So this is going to be spreading out the cloud in different directions. These secondary shapes also have random scale per shape. If we set this to 1 and 1, you'll see that all of these are a uniform scale. All right, so that gives you an idea of the general shaping for clouds. Over here under the output, we have a fuse distance, and this is just going to be the minimum distance before 2 points get fused together to create one sphere. So as we increase this, we'll be reducing the number of spheres that we have. It reduces overlapping and allows for more gaps in the clouds, which is actually beneficial if you want your clouds to have more interesting shapes. We also have remove below scale, and this is just a threshold. And if a point is smaller than this, so if its p-scale is lower than this value, then that point gets removed. Now, this doesn't really explain to us what the input is and what all of these settings over here are for. So let's take a look at that. If we go ahead and just drop a grid, and then we scatter some points, so I'm just going to scatter 10 points on here, we can go ahead and feed that into our cloud shape generate. By default, I've given our clouds an initial size of 10. I'm just going to reduce that size back down to 1 so that we can see these 10 clouds that we've created. Each and every point on this grid has a cloud generated for it. And each one of these clouds actually has a cloud ID. You can see it over here in our point attributes. It goes from 0 to 9. And we can see this if we just give them a random color, so random from attribute, and we're just going to use cloud ID. You can see that each and every set of spheres has a different color. This is useful because you can run operations on each one of these shapes individually using a for each loop. So you can use for each named primitive, and all you'd have to do on this block end is change the piece attribute to cloud ID and make this a point piece element, right? So now you can see that you can actually single out each and every one of these. right? So that's going to be useful if you want to run operations on each and every cloud. Now, as for actually causing some sort of variation in each one of these clouds, we can do that. That's what the settings over here are for. The most obvious way to see it is with rotation. If I rotate this, you'll see that they all rotate in the same direction uniformly. Oftentimes, this is not what we want. So we can go over here to say set uniform and say set varying. This adds variation. This variation is going to be the base amount minus 25 and plus 25 as the minimum and maximum. So it's actually going to be a range of 50. We can set this to 180 for a range of 360. And this just rotates our clouds randomly. But that's not the only way that we can do this, because this set varying is available for each and every one of our options. Additionally, we can also gain more control over the randomization if we click on this icon of the die on the side. Clicking on that adds this attribute adjust float. And what this does is it gives a rotation value to each point and stores it in an attribute called rotation. But each and every one of these can have an attribute added. Even the cloud species over here, if you click on the die, it'll add one over here, which randomly gives a value between 0 and 2. You can see it over here. And that corresponds to either the humulus, mediocris, or congestus. What's pretty cool about that is that you can actually use an attribute wrangle as well, because this is just an attribute. So you can just say at cloud species equals 2, and this will turn them all into those tall clouds, into congestus clouds. Or you can even select a couple of these points, add them to a group, and only those will have them explicitly specified. You can once again switch that off, and you can see that only those are now congestus clouds. Okay, so that covers how we can actually cause randomization and all of those things with this cloud shape generate. But what is this node actually useful for? So let's go ahead and just take a single cloud like this. I'm going to move it around until I have some interesting variation in the shape of the cloud, something like that. All this is a bunch of spheres, right? So if we actually check over here, we have points, and they're being represented as spheres based on a p scale. Now, this isn't going to be good enough for an actual cloud, so what we'd want to do is add more detail. One of the ways that we can do this is a replicate shape, so a cloud shape replicate. All this is going to do is it's going to take those original shapes and add more detail to it. This is useful because we can just adjust this over here, and for the output, say keep input geometry, give it some directional influence, right? So we maintain the general shape, we add some more shape, and then we can use something like a VDB from particles. And because these are just points with p-scales, this will turn it into a volume. And we can increase the voxel resolution and then change this from a surface to a fog, right? So once we have this as a density, we can use all of the other tools under the cloud toolset. You can see that there's a whole bunch over here. Some of the most useful ones are going to be ones like the billowy noise. So plug this into a billowy noise and override the look over here so we can see what's happening. And then we can play around with these settings. So increasing this amplitude over here, and the element size. Enable some Wall-E details. And then we can also do something like enabling iterations, and this will just iterate over this noise multiple times so that we have a more interesting noise pattern. It'll also use these attenuation settings, and these are multipliers for our noise. So each time it runs an iteration, it'll actually only use 0.35 times your amplitude and 0.35 times your element size. So it's going to be scaling down and gives you smaller and smaller detail, right? So you end up with something like that. Now, there's a whole lot of other tools that you would use for generating clouds, and I do actually have something over here that you can go through if you'd like to check it out. Over here, I do a bunch of what I showed over there, right? So some randomization, we flatten it, turn it into a VDB, adjust the density, add this billowy noise, and then we clip it on this axis over here, create some wisps at the bottom, merge it in with the original billowy cloud, do some post-processing on it, and then adjust the volume. And if we go ahead and just take a look at how this looks rendered, that's the sort of cloud that we end up with. The only other thing to take note of is that you would use a Karma cloud material. So that's just a Karma cloud material over there. Or in a regular Karma material, you would just go over here and enable the volume limit and set it to a fairly high value. Now, this isn't only useful for clouds, and that's the last thing that I just want to cover. If we go ahead and drop a geometry node over here, we can actually use this for other interesting things. So we'll use a cloud shape generate. What you can do is you can run this through something like a bubble remesh, so remesh bubbles. And then all you'd have to do is just increase the p scale, so double it, and you end up with a fairly interesting result. This over here can be rendered in fairly artistic ways, and this isn't really a cloud, but you are still using the cloud shape generate as a source for this. Now, alternatively, because these are just points with p-scales, we can even do a copy to points. Copy to points over here, so this will go into second input, and then use something like a torus, plug it into first input, and you end up with something like that. You can even use an attribute randomize, because once again, these are just points. So attribute randomize over here. Set this to orient, make it 4 dimensions, and make it inside sphere, and you can end up with a result like this. Now this is cool because you can end up with results that you might not expect from a cloud shape generate node, but this has a lot of functionality for just generating general shapes. Right, this is really nice for just generating spheres that are kind of packed closely together, and you have all sorts of controls for the shapes. So feel free to get creative with it. Once again, if you do want to see how the general cloud workflow works, you can use this file over here. It will be linked for download. But again, don't be limited to just the cloud workflow. But that's all for this video. In tomorrow's video, we'll be looking at the Pyro burst source node and all of the ways that we can use that node. So I'll see you there. Bye.